Hello, welcome to Astronautic for Exploit. This is Dr. Ayenshola Ogodele. Virtualization of spacecraft mission control, telemetry processing, and data handling via replacement of traditional hardware-dependent systems with virtualized infrastructure. Spacecraft mission control, telemetry processing, and data handling, interconnected systems that enable ground teams to monitor, control, and communicate with a spacecraft, are being revolutionized by the introduction of virtualization into the spacecraft ground segment operations. Spacecraft mission control is the central hub for monitoring and operating a spacecraft from the ground. It receives and processes telemetry data in real time, uses data visualization to display the spacecraft's status, plans and schedules mission activities, sends commands to the spacecraft to execute tasks, and manage anomalies and diagnoses problems. Telemetry processing converts raw data from the spacecraft into meaningful human-readable information. Virtualization of spacecraft mission control, telemetry processing, and data handling involves replacing traditional hardware-dependent systems with software-defined, cloud-based, and virtualized infrastructure. Virtual mission control centers host all mission operations, including telemetry and command, maneuver planning, and orbit determination on virtual or cloud-based infrastructure. The focus points are as follows: spacecraft mission control virtualization, spacecraft telemetry and data processing virtualization, spacecraft data handling virtualization, and digital twins for design and operations. Spacecraft mission control virtualization. Virtualization is revolutionizing spacecraft mission control by replacing dedicated hardware with software-based systems that run on commodity servers or cloud infrastructure. Virtualization approach uses technologies such as virtual machines and digital twins to manage mission-critical functions such as telemetry processing, commanding, and data handling. The picture here illustrates ground data systems and mission operations. A virtual mission operations center is a cloud-based or on-premise, software-defined environment that provides flexible command and control capabilities. Virtual Mission Operations Center hosts all mission operations, including telemetry and command, maneuver planning, and orbit determination, on virtual or cloud-based infrastructure. By using virtual machines or container technology, such as Docker and Kubernetes, traditional hardware-based systems are replaced with more agile software. Galileo ground segment is illustrated in this picture. Mission control virtualization, virtual mission planning. U.S. Naval Research Labs provides web-based mission planning for satellites from CubeSats to larger constellations. Remote operations. NASA has developed a virtual mission operations center collaborative environment which enables geographically dispersed teams to monitor and troubleshoot missions remotely via a secure internet connection. Traditional versus ground station as a service model is illustrated in this picture. Mission control virtualization key examples: cost savings and automation. Virtualization offers significant cost savings by reducing the need for physical hardware, lowering power consumption, and decreasing licensing fees. It enables automation for routine tasks and failover functions. Ground station as a service applications across industries is illustrated in this picture. Advantages are as follows: flexibility. Teams can manage missions remotely from any location when using virtualization, with access to a hosted anywhere platform. This decentralizes the traditional operations center, allowing for a mobile workforce and flexible staffing. Rapid deployment. For new missions, virtual ground systems can be deployed in minutes or hours instead of the days or weeks required for physical facilities. Ground system architecture is illustrated in this picture. Collaboration. Web-based interfaces and centralized data management improve collaboration among mission operators, engineers, and scientists, no matter their physical location. Simulation and testing. Tools like Antares full mission virtualization enable the simulation, testing, and optimization of multiple missions. Digital twin system is illustrated in this picture. Spacecraft telemetry and data processing virtualization. Telemetry and data processing. In traditional mission control, telemetry data is processed by dedicated physically connected hardware. Virtualization shifts this work to cloud-based, scalable systems. Scalable processing. Services such as Amazon Web Services can host the entire ground segment, allowing operators to spin up and down virtual servers to process data on demand. For example, Ultrasat uses a real-time database to manage its OneWeb satellite constellation. Copernicus ground segment is illustrated in this picture. Containerized and telemetry as a service. Containerization simplifies the deployment and management of telemetry processing applications. LeapSpace, which uses Google Cloud for its ground station network, deploys its scheduling and data transfer services using Kubernetes. This enables efficient resource use and near zero downtime. Telemetry as a service. Companies such as SpaceTK offer telemetry and command web services, allowing users to integrate processing functions into the ground segment without heavy capital investment. Select ground segment facilities worldwide is illustrated in this picture. Spacecraft data handling virtualization. Spacecraft data handling. By moving data handling to the cloud, space missions can leverage advanced commercial solutions for data storage, distribution, and analysis. Placing large telemetry and science data sets into the cloud enables co-located computing resources, revolutionizing how scientists access and analyze data. NASA Earth Science Data and Information System project is moving data to the cloud in order to facilitate broader use. Integrated ground system is illustrated in this picture. Spacecraft data handling, on-orbit processing. Virtual missions on commercial platforms allow customers to deploy software applications, including artificial intelligence and machine learning algorithms. These directly to orbiting satellites. It enables Earth processing for applications such as detecting vessels or monitoring wildfires. Enhanced analytics. Cloud platforms can combine on-orbit data with other terrestrial datasets for enhanced analysis. Control center at NASA's Jet Propulsion Lab is illustrated in this picture. Digital twins for design and operations. A digital twin is a virtual replica of a physical spacecraft which uses live telemetry data to mirror its real-time behavior. This technology significantly accelerates mission development and enhances operations. Design and testing. Engineers can simulate and test satellite designs in the virtual environment in order to validate its performance. Satellite ground station is illustrated in this picture. The digital twin continuously receives live telemetry from the orbiting satellite, allowing it to predict and troubleshoot potential issues. Operators can run what-if scenarios to test responses to anomalies in a virtual risk-free environment. A hyper-realistic digital twin can be used in order to train flight controllers and engineers on various scenarios. Australia's fleet of Internet of Things ground station is illustrated in this picture. For more information, contact Astronautics for Exploit. You've been listening to Virtualization of Spacecraft Mission Control, Telemetry Processing, and Data Handling via Replacement of traditional hardware-dependent systems with virtualized infrastructure by Dr. Ayenshola Ogundele. With the focus point, Spacecraft Mission Control Virtualization, Spacecraft Telemetry and Data Processing Virtualization, Spacecraft Data Handling Virtualization, and Digital Twin for Design and Operations. Thank you.